Hello, welcome. In this video we are going to discuss how higher order derivatives can be determined using Sagemath. For example, consider this question. Compute the first 8 derivatives of the function fx equals cos x. And what is the 255th derivative of the same function? If we try the command fx equal to cos x and dif of function or dif of statement can be used to find the derivative. Its syntax is dif of fx comma x comma I for I in 1 to 8. We get a sequence of functions as given here. These are the derivatives which are calculated one by one and displayed by the Sagemath system. So this this function, the first function stands for the first derivative of cos x, and this is then the second derivative sin x. This one is the third derivative, then fourth derivative, fifth derivative, etc. So see, first, second, third, fourth, fifth, sixth, seventh and eighth are the derivatives determined by the Sagemath system and displayed in an order. But you know, actually we want the 255th derivative of the function. But for that you can use some simplified calculation, because if you try to apply the method which is mentioned here, the statement or the output will contain around 255 or 256 functions. That will be a very lengthy statement. So to avoid that kind of lengthy statement, we can apply a simplified method. We know that the derivative of the function cos x repeats in intervals of length 4, because that function is periodic with modulo 4. So using the periodicity of that function, we can simplify the problem of finding the 255th derivative. So 255 has a remainder 3 when it is divided by 4. You can see that 255 when divided by 4 can give us 3 as the remainder. So 255th derivative of the function, given function, equal to third derivative of the function actually. Thus we can simplify that problem. That hardness of the problem can be simplified. How? 255th derivative of the function equal to the third derivative of the function, that's equal to sin x. So we can then use this list to obtain that derivative, obtain the answer. Referring that list, you can write the answer. So we can so next we are going to demonstrate it. Okay, let's take that Jupyter notebook, and then after opening the Jupyter notebook, we define the function f of x equal to, since our function is cos x, we define that function in the input line. Okay, f of x equal to cos x. After defining that, if you want to display the content, you just type f and x, f of x, and then you can take the output. Then you get cos x. So that function, the selected function itself, will be displayed. And now we are going to take the next. We are going to type the next statement. And that statement contains in bracket dif of command, dif of differential. So this command can find the derivative of fx, and how the degree of the derivative can also be given, and with respect to which variable it must be differentiated, that can be given in that in bracket after giving that function. So after including the function f(x), then we write the variable with which it must be differentiated. So x is with respect to x we want to differentiate, and I is the degree of the, or I is the level of differentiation. But here in this single statement, we can we can differentiate the function in a number of times, in a specified number of time, ranging ranging in a list of numbers. Okay, that list is 1 to 8. Continuous integers. In the list of continuous integers, 1 to 8, I is allowed to vary. So so considering the various values of I, it can differentiate. So that output will be displayed. So we are going to try this. Okay, we copy it and okay, next we take the output and we have got that output. Okay, next then the method to obtain that derivative is explained here, so I won't go to that details again. But if you want to find the 255th derivative, then that direct method, there exists direct method to obtain that derivative. So this is that simple statement, very simple statement in that can be used in Sagemath to obtain 255th derivative. So this is the previous one explained here is a method, but you can see that after applying this method, after applying this simplified statement, you can see that this method is actually very lengthy. So it's unnecessary actually, and is time consuming. So it's better is to use this kind of statement if you want to obtain the ith derivative or nth derivative of a given function. So we can directly copy this and then substitute. Okay, and then paste there, and you can take the derivative sin x. You can see that sin x is the 255th derivative. So the syntax of obtaining the derivative of a function is, given function is diff of fx then x 255. Okay, let's now next consider another function. See, another function we want to differentiate. Okay. For that a function, I will type a function, I will select a function. Before that, without defining a function, you can find the derivative. See how diff. First we use diff and then put the bracket, and inside the bracket you can give that function. We want to differentiate x square, the function x cube. Okay, x cube plus x cube plus 3 star 3 into 3 star x star x star 3x y, right? Okay, 3xy plus 5y raised to 4 plus 5 star y cap for 5. Okay, yeah, 5 into y cap. So while typing such functions, you should carefully type it. That's very important. Okay, then I then give a bracket I want to close that bracket also, otherwise I will give here that closing bracket. Okay, and after that, now I have given that function to differentiate. Then now I decide to differentiate this function. Which function should I differentiate? The function is x cube. X cube, you can see that function here, x cube plus 3xy plus 5y raised to 5. X cube plus 3xy plus 5y raised to 5. 5y raised to 5 is a function given to differentiate with respect to x. Suppose we differentiate with respect to x, you have to write x next. Then suppose we want the first derivative. Okay, if you want the first derivative with respect to x, okay, you can write then 1, and then you can directly take the output. Okay, what's the reason? This function maybe y may not be defined there. That's the y is not defined. Yeah, y, the function, the variable y is not defined actually. That's the reason. So let's copy this and try. Let's copy, and before that we have to define var variable. Let's define y as a variable, equal to then in quotation y y equal to var y. Okay, this is next y here, y equal to var y is there any mistake? Let's check. No, invalid var y. That syntax is okay, let's check that. So we had to check that the variable defining var. Okay, there we missed that bracket. That is the problem. I think that we missed that bracket. var bracket. You can see this is the syntax. Okay, let's come back to we will come. Okay, here we will come back to that step and we will try again. Copy this and you copy that and paste. Okay, then y equal to var and then sorry, in bracket you have to write y. Okay, then let's try that. Okay, no problem there. Now it doesn't show any error message, and that means our variable definition is correct. And after that, let's try with this and copy, and you paste it. After that you take the output, try to now we have obtained that. So the problem was that y was not defined as a variable, but automatically x is it is recognized as a variable here because it is given here as to differentiate with respect to x, and x was thus detected as a variable, but y was not detected as a variable. Now let's see whether this the answer is correct. Okay, since we differentiate that, let's now apply the direct method of getting the derivative. X cubed, its derivative is x cube has derivative 3x square, right? Okay, so the first term is 3 into x into x square, 3 into x square, so that's correct. And then second one is 3 star x star y, its derivative with respect to x is 3y. Oh, that's correct. Then the third term is 5 into y raised to 5 y raised to 5, but its derivative with respect to x becomes 0, so that term will be absent, hence we get the derivative. Now you can see that the second derivative can be obtained using in a similar way. We can obtain the second derivative of that function. Second derivative of the given function is x cube plus 3xy plus 5y raised to 5. It's if you want its second derivative, you can just copy that and you can replace that one, the number 1 given there, by 2, and that stands for the second derivative. So x should continue there, but 2, the number 1 must be replaced by 2 to obtain the second derivative. Okay, so that number we can say that n, in general n must be there, and that number n specifies the nth derivative, or the degree of that derivative that we determine. Okay, now by taking the output you get that 6x. Is it correct? The second derivative of this function is of the first function is the first derivative of the first derivative of that function. Okay, so first derivative of this function. What is the first derivative of this function with respect to x? You will get 3 into 2 into x, that's 6x. It's correct. Yeah. Okay, thus we have obtained the answer 6x, that is correct. Okay, this way we can find the derivative of any function. Either you can first 2 ways you can adopt for obtaining the derivative. First you can define the function. First one can define the function, and then you can use that function inside that command, diff command, to obtain the derivative and specify the variable with respect to which we want to differentiate. Also you want to you have to specify the number of derivative, that means the degree of the derivative that you are going to find. But you know, this can also be done by directly giving that function inside that statement. So that way, that is the way we have here explained the problem here. Okay, next, coming back to our discussion, see the problem. Next, yeah, this here here another problem is given. Compute the first 3 derivatives of fx equal to x into sin x. X into sin x is the function given. So you have to find the first 3 derivatives. If you want to find the first 3 derivatives, okay, one by one you can give that function, give that the first derivative. First you can find the first derivative, then the second derivative, and third derivative. That way you can give, or otherwise you can give it in one statement. The answer, first 3 derivatives will be displayed as a table or as an array of functions. You can take that output as an array of function. But here that method, the method directly finding one by one, the method of finding the derivative one by one is explained here. So we can do that. We can use that. See fx equal to x into sin x. So here we take fx equal to x into sin x. I'm substituting that. Fx equal to x into sin x. So first we define that function. So when we define this function, already previously some function is stored at the location of fx, but that will be erased, and the new function will be stored there. So okay, taking that out, but then we then use that we use this command to obtain the derivative. You can use this command diff fx and then comma x. df of fx comma x. Okay, if you want the first derivative, but anyway you can apply this, you can take the output and obtain the first derivative. But if you specifically you could, if you want to say which derivative you require, then you can give the number 1 there for first derivative. For the second derivative you have to give there the number 2. So by taking the output we get that this output. Let's compare it with the manual. Okay, 2x cos x plus sin x is the output, x cos x plus sin x. Okay, next for obtaining the second derivative, you can just copy that and copy and paste it, and you can replace 1 by 2. Okay, and then you can take the output. And this is the second derivative. You can directly you can or manually you can check, and then if you want the third derivative, you can copy and paste, and 3 can be 2 can be replaced by 3 and the last part. Okay, and then you can take the output. So these are the derivatives, the third derivative. Okay, and this way you can find the nth derivative. You can continuously, so suppose if you want suppose we want 20th derivative. Suppose somebody is asking you to find the 20th derivative, you can then use this statement and then replace 2 by 20. Okay, then you can take the output. So this is the 20th derivative. The 20th derivative of that function is now obtained. See how easy is this, how this method or the Sagemath system is helping us to obtain the derivatives, higher order derivatives. It's very interesting. And then okay, this is about finding the higher order derivatives. Okay, next we see the function. This can be this, you can see finally before stopping this video, you can see a single step calculation for obtaining sequence of derivatives, or first few derivatives of the given function. Here the function is fx, that is the same function. Here I copy and I copy that statement, and then I place it, I substitute, I paste it in the input cell. Then suppose we take that output. See, you can see a table formed here. The table, and the table contains the derivatives. First derivative is, so see, let's check that statement. Let's analyze that statement. So you can see a bracket opens, and then a square bracket opens. So after that diff command is used. Then we give, then we write fx in a bracket, and which is then separated by x and which is then separated by x and I. Separated by commas, the variable x, and then I is also given. Okay, then bracket is closed. After that, for I in the range 1 to 5, for I in the range 1 to 5, we can find the derivative. So the first derivative, second derivative, third derivative, fourth derivative, and fifth derivative. And so that is these are the derivatives that we can obtain using this command. So up to 5 derivatives up to 5 of the given function can be obtained, and the content can be displayed in the form of a table. Okay, by this we are going to close this short video on finding higher order derivatives of any given function. You can use this method to obtain the derivatives of a given function. Okay, thank you for watching. Thank you.